the variables by yourself. This one, they are giving you everything. All you need to do is just start solving from here. So it's be cool though. This is and this question is last year question. They will just repeat it for you. Oh God, let me just copy the question and see if we can solve it. 12. Each question is 12 marks in this exam. This one, it's also crazy. This one is about network analysis, anyways. But very crazy. You look at the network diagram and blah 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 blah. It's cool though. So I'll screenshot the question. So let's see if we can solve this question. We'll try. Should not take us too much time like the other one. But I mean, you can still see my screen, right?
Yes, you can.
So they said solve the linear programming graphically, and then we have the exact is equals to this, blah blah blah, and then bam. Okay, so let's just say we have two products. We have product A and B, right? Product A and B. That is what we have here. So our objective objective function is this. So objective function. We'll just use that knowledge that we have here. So we have z is equals to 3x 3x1 plus 2x2. So we have subject to we have our constraint. So which is x1 is equals to sorry x1 plus 2x2 is less than or equals to 10. Then we have 3x x1 plus x2 less than or equals to what? 15. Then when x is greater than or equals to 0, and then x2 is greater than or equals to is greater than or is the thing going down equals to 0. Okay. So now let's look at this step by step, just like so. Like let's assume that this is a product, right? We're looking at product here. This is production and this thing. So the course name is production and operation management. So let's assume this is a product, and then x1 is the number of product A, and x2 is the number of product B. Assumption. You know when you're writing like that, people are like, ah, this guy, this thing is doing very well. This guy is a good guy. You know, that kind of stuff. So now, what do we have here? We now have production, our allocation of resources. So let's say, okay, now when x, we are converting this to very simple equation, right? So we want to say that these ones are our constraint. Let me put it aside before you now join it. So remember to know your objective function, which is this one. Now remember this one here, they say you should minimize the objective function. This one, sorry, this one is maximize, it's not minimize. The other one we saw was what? Minimize. So let's continue. So now we're going to form an equation here, right? So let's first look at this first one. So x1 plus 2x2 is equals to what? 10 now. So when x1 is equals to 0, when x1 is equals to 0, right? What do we need? When x1 is equals to 0, then our x, what is going to be our x2? X2, so we'll just substitute. So x2 now is going to be 2x. 2x2 is now equals to what? 10. Can you see what we have here? So by the time we do this, 2 divided by 10 will now give us what? X2 now is equals to 5. So that's it. So with points now, the point on the point we have here is going to be uh when x is equals to 0, when x is equals to 0, our x when x1 is equals to 0, our x2 is equals to 5. So we have this. Okay. So in the same constraint one, this is constraint one that we have here. Let's say this is our C1, constraint one, right? When you see C1. So in the same constraint one, now we are looking at what? X2. So when x2 is equals to 0, right? What is going to be our x1? Then our x1 now is going to be equals to 10. Very simple, because now we have x2 is equals to 0 in this place. So 2 times 0 is equals to what? 0. Then x1 is now equals to 10. So we now have this. So here we now have 10 by this looks like what we already saw. Okay, 10 and then this one 0 equals to this one now 0. So now we are looking at what? Constraint 2. C2 now. So our C2 now is going to be what? Now, in this equation, we have 3x1.
Sorry, please, can I ask a question, please?
Yes, please ask.
Okay, so when you got x1 equals to 10,
Mm,
did you substitute that 5? Like, did you bring 5?
no,
Abi?
no. See.
So, how did you get the x1 equals to 10? That
Okay,
is
the
what I'm
x1 is
asking.
equals to. Okay,
Eh,
now look at this is the equation we are dealing with, right? So this is
okay.
x1 plus 2x, right? So
Mm-hmm.
now, x2, I said when,
X2, okay, okay,
when
okay,
x is
okay.
equals to what? 0.
0,
We now
okay.
put 2 in
That means
place.
we'll substitute it with 0. Okay.
That's good. That's what we
Thank
got the
you.
10. Right?
Thank you.
Very good. So so now we are now looking at our constraint 2 now, right? Now the constraint 2 now, when x is equals to 0, this is supposed to be equals to 15 now. 15. So when x1 is equals to 0 here, what do we have? 3 times 0, 0. And then x2 is automatically what equals to 15. Our x2 is what? 15. Our x2 here is 15, right? It's easy. X2 now is 15 when x1 is equals to 0. Then when so what about when x2 is equals to 0 now? X2 equals to 0 equals to 0. Then we substitute now, right? So what we'll do now, we have to say 3x, we have 3x1 plus 2x is already what's in the equation now is x. So x2 is 0 already. So there's nothing in 0. So 0 times 0 times 1, that is 0. So this is going to be 0. So our x1 now is going to be equals to, um, we'll just do simple maths now, equals to 15, right? Divide both sides by 3. 15 divided by 3 should give us what? 5, right? Then our x1 is now what? 5. Our x1 is now 5. So in this one here, we have when x is equals to 0, we have 0. Always do these things. These are actually anything you're supposed to do. So we now have this one now when x1 is equals to 5, then we now have 0 like this. Okay, so we look at, so now we want to actually look at the equation, which is we want to solve it simultaneously, right? Just the way we did the other one. Let's solve it simultaneously to see. So we have these equations here. Uh, Simultaneous equation now. Let's do it here. So we have x1 plus 2x2 equals to what, 10, right? And then we have 3x1 plus x2 equals to what, 15. So we want to solve it simultaneously. So what we do is that we want to, from equation 1 now, let's have something like this. We have, just like we read, this is 1 and this is supposed to be our equation 2, right? So now we can say, okay, from our equation 1, from equation 1, let's do this. Let's find our x1. So our x1 in equation 1 is now equals to uh, something that will not be hard. So it's going to be 10 minus 2x. So we have defined our equation 1. So we now substitute. Let us substitute now. We want to substitute equation 3 now into what? Into 2. So this is our equation 3. We want to substitute it into equation 2. So what we now have is going to be more of this. Uh, so where it is our equation 3, which is going to be 3, we already have our x1. So our x1 now is going to be what? 10 minus 2x, right? 10 minus 2x2, right? Close the bracket and then plus x2 is now equals to what? 15. That makes sense, right? That makes sense. So now, since we have this way, uh, how we do it now is 3 times 10 should give us 30, right? Then minus 3 times 2 should give us 6. That is 6x. 6x2. Add 6x2 plus x2 equals to 15. Right? Does that make sense? So now we have minus 6x2 plus x2. That means we now have 30 minus what? Uh, 5x. But we already minusing the one that is from the other side. This equals to what? 15. So, Abi, does this make sense?
Yeah, sure.
Okay. So we have 30 minus what? We have 30 minus 5x and equals to 15. So now we want to kind of collect like terms. We want to collect like terms. So we can say we have 5x now. We have 5x is now equals to 5x2 is now equals to what? So that should be 30, right? 80 minus 15. 80 minus 15. And then 30 minus 15 should give us uh, 15, right? Then we now have x is now equals to 15. And 15 divided by 5, we now have our x2 is now equals to what? 3. That should be the answer. That should be 3. Okay? Should be 3. Simple. Okay. So now we now just what we can do now, we can take the equation one and then substitute. So from equation one, that is x1, right? What we are looking for now is x1. So we now have x1 plus 2 times 2 times 3, supposed to be that, and then equals to 10, right? So x1 now is now equals to 2 times 2, 2 times 3 is going to give us what? 6, right? It should give us 6. That should give us 6. Then this should be 6. Then this should be 6. Yeah, it should be 6. And then we cannot have 6 like that. So by the time we are bringing it this side, it's supposed to be, we can just do 10 minus 6. We can do 10 minus 6. Then our x1 will now be 4. That's our x1 is now 4. Right? So that's one. X1 now is equals to 4. So now, remember, when we have this, guys, we have here, and these are the points we're looking at. We have, uh, we are looking at the minimum. We look at this one. From here, we have on this C1 here, we are picking this, and this. Do you understand? We pick this and this. Now, while we're picking this, we want to determine now what the question that they're asking you. You want to know all this method that you have used now, which one is actually giving us the minimum, the max. Here we are looking at the maximum, we are looking at profit, we are looking at the highest. So, like for the other one now, that was minimum, we pick the highest. We pick from this first one here, we pick 8, right? We pick 0 when x is, we pick 0, 8, and this one we pick 10, what? 0. We didn't pick the small ones. Now, when it comes to this one, we are going to pick, when it's maximum now, we're going to pick small one and small one. This is what we're going to pick. Do you understand? That's just the logic. It's very simple. Do we understand? Should I continue? Should we
Yes,
just
please.
okay? So now when we pick that, what we're going to test now. So now we have our what? Our objective function, which is this guy. So this one it's our target here. So this is our objective function. So here now, if we are picking this now, when our x1 is 5, our x1 is 5, right? So we can say okay, our z is equals to let's pick this one here first. So we can say it's 3 x5 as well. X1 is 5, and then plus 2 times 0. What do we have? So the 2 times 5 is going to be 15. 15. 2 times 5 is 15, right? So this is what we have here. We have 15. So we pick from this one is 0.5. So this is z is now equals to 3 0. That is when x is 0, then this x2 is 5. Then this is 2 times 5, right? Then 2 times 5. Then what do we have? 2 times 5 is going to give us 10. So the one that we now solved here, right? We are looking at the maximum guy. So this is 10, this is 15, this is 18. So let's solve for this one. And here we got X1, look at our X. Z is equals to our is uh X1 is 4 plus 2 times 3, right? So this is going to be 3 times 4, 2 times 4 plus 2 times 3 give us 18. So which one is the highest?
18.
18. So the maximum profit of X, the maximum profit of Z, now the maximum profit of what Z is now 18, and that is your answer. The other one was minimal. We are looking at the small one. This one is maximum. We are looking at the max. So this is 18 that we got. So the optimal solutions are now when x is equals to 4, x1 is equals to what? 4, then x2 is equals to 3. It will give us 18. That's this is our answer. We have solved our question. Finished. Finished. Complete your marks. Waiting for us. That was all.
Okay, thank
So
you.
I'll share the past question paper when I finish solving. I'll share so that you can look at it again and maybe try to